Every civilization in human history has believed in one way or another that it stood near the center of time. Empires imagined their rule would last forever. Cultures built monuments meant to endure for eternity. Yet history tells a different story. Cities fall, languages disappear. Entire civilizations that once shaped the world fade into ruins and forgotten artifacts. From ancient Mesopotamia to Rome, from the Maya to countless lost societies, human history has been a cycle of rise, transformation, and decline. But something unusual has happened over the past few centuries. While individual civilizations have collapsed, humanity as a whole has continued moving forward. Knowledge accumulates, technology spreads. Even when societies fracture, the broader trajectory of our species seems to continue advancing. This raises a fascinating question. If humanity continues long enough, could there eventually come a time when there is only one civilization left? Not one empire or nation, but the final form of human civilization itself. The last stage of a story that began hundreds of thousands of years ago, with early humans learning to survive on the African savanna. At first glance, the idea of a last civilization might sound pessimistic, even apocalyptic, but the concept does not necessarily imply sudden destruction. Instead, it reflects a deeper reality about the long arc of time. If humanity survives long enough, thousands, millions, or even billions of years, then the sequence of civilizations cannot continue forever. Eventually, there may come a point when the future contains fewer civilizations ahead than behind. In that sense, the last civilization may not represent catastrophe. It may represent culmination. To understand why, consider the extraordinary scale of human progress. For most of our species' existence, humans lived in small communities using stone tools and fire. Agriculture emerged only about 10,000 years ago. Industrial technology appeared just a few centuries ago. Spaceflight, computers, and artificial intelligence have all developed within a single lifetime of modern history. In cosmic terms, this transformation has happened almost instantly. If such acceleration continues, future societies may achieve levels of technological sophistication that would appear almost unimaginable to us today. Entire planets could be engineered to support life. Artificial habitats might orbit stars. Vast computational systems could simulate environments, explore scientific problems, or even sustain forms of consciousness far beyond biological limits. The civilization that eventually emerges at the far end of this process might look very different from anything humanity has known before. It may not resemble modern nations, cities, or cultures at all. Instead, it could be a vast, highly integrated system of intelligence spanning multiple worlds, managing immense technological infrastructures and possessing knowledge accumulated across millennia of scientific discovery. Yet even such a civilization would still exist inside a universe governed by physical laws. No matter how advanced a society becomes, it must ultimately operate within the constraints imposed by cosmic reality. Stars burn through their fuel. Planets change over time. Galaxies evolve across billions of years. These forces operate on timescales so vast that human history barely registers against them. But for a civilization that survives long enough, they become impossible to ignore. This is where the idea of the last human civilization becomes truly fascinating. It invites us to imagine not just the future of technology or society, but the farthest horizon of human existence itself. If humanity continues to survive and evolve, what kind of world will those distant descendants inhabit? What knowledge will they possess after millions of years of scientific progress? And what challenges will remain when most of the universe has already aged far beyond the era in which we live today? To begin answering those questions, we must first imagine what a civilization might look like after immense spans of time, when humanity has reached levels of development far beyond anything we currently recognize. If humanity survives long enough to reach its final stage of civilization, it will almost certainly inherit a world transformed by thousands or even millions of years of technological progress. The societies we know today, nations, economies, and political systems, are products of a very short moment in human history. A truly long-lived civilization would likely operate on entirely different principles. To imagine such a society, it helps to start with energy. Every civilization depends on energy to sustain itself. Early humans relied on fire and muscle power. Industrial societies harnessed coal, oil, and electricity. But a civilization that survives for immense spans of time would likely command energy sources far beyond anything used today. One possibility is the complete utilization of a star's energy output. Physicists have proposed theoretical structures called Dyson swarms, vast networks of satellites or habitats orbiting a star to capture much of its energy. Such a system could provide more power than any planetary civilization could ever need. With that energy, a society might support trillions of inhabitants, enormous computational systems, and immense scientific infrastructure. But energy is only one dimension of an advanced civilization. Over long periods, technology itself may reshape the meaning of civilization. Artificial intelligence could become deeply integrated into every system that supports life. Decision-making, planning, engineering, and exploration might increasingly rely on highly sophisticated machine intelligences working alongside biological beings. Rather than replacing humanity, these systems could become partners in sustaining civilization over extremely long timescales. Machines do not age in the same way biological organisms do. They can preserve knowledge, maintain infrastructure, and operate reliably for centuries or even millennia. In a far future society, much of the complex maintenance required to sustain civilization might be managed by autonomous systems. At the same time, human life itself could change dramatically. Advances in biotechnology and medicine may allow future humans to extend their lifespans far beyond current limits. Diseases that once threatened entire populations might become relics of the distant past. Genetic engineering could allow people to adapt to different environments, whether on other planets or inside artificial habitats. This introduces a striking contrast between present civilization and the civilization of the far future. Today, human societies struggle with scarcity, limited resources, limited energy, and limited lifespans. A mature technological civilization might operate in a world where many of those constraints have been radically reduced. In such a world, the structure of society itself might evolve. Cities may no longer be confined to planetary surfaces. Vast orbital habitats could host entire communities floating in carefully controlled environments. Some people might choose to live on planets, while others inhabit rotating structures that simulate gravity. Civilizations could spread across entire solar systems, connected by advanced communication networks and transportation systems. Over long periods, cultural identities may also evolve in unexpected ways. Communities separated by different worlds or habitats could develop distinct traditions, philosophies, and forms of art. Even language itself might gradually change as societies adapt to new environments and technologies. Yet despite these differences, a mature civilization would share a unifying foundation, an immense accumulation of knowledge. After thousands or millions of years, the scientific understanding possessed by such a society would likely be extraordinary. Fields that are only beginning today, quantum computing, artificial intelligence, advanced materials science, may evolve into disciplines capable of solving problems we can barely imagine now. Future scientists might understand the nature of space, time, and matter at levels far deeper than today's theories allow. Entire branches of knowledge could emerge that we have not yet discovered. But no matter how advanced such a civilization becomes, it cannot escape the deeper environment in which it exists. Technology can reshape planets and capture stellar energy, but it cannot rewrite the fundamental laws governing the universe. The cosmos itself continues to evolve on timescales far longer than any human institution. Stars eventually exhaust their fuel, planetary systems shift and change, galaxies drift through space, interacting with one another across billions of years. For a civilization that survives long enough, these cosmic processes become part of its long-term future, which leads to a deeper realization. The final human civilization will not only be shaped by technology and culture, but also by the long-term evolution of the universe itself. Even the most advanced civilization cannot escape the deeper forces of the universe. Technology can extend lifespans, reshape environments, and capture enormous amounts of energy, but it cannot eliminate the fundamental processes that govern cosmic evolution. Over sufficiently long timescales, the universe itself becomes the dominant factor, determining how long any civilization can endure. The first of these limits comes from stars. Every civilization that depends on stellar energy ultimately relies on a resource that is temporary. Stars shine because nuclear fusion converts hydrogen into heavier elements, releasing vast amounts of energy in the process. But this fuel is not infinite. Over billions of years, stars slowly exhaust the hydrogen in their cores, eventually transforming into red giants, white dwarfs, neutron stars, or black holes. For Earth, this process will become critical long before the Sun actually dies. In roughly 1 billion years, the Sun will grow brighter as it ages, gradually heating our planet until Earth's oceans begin to evaporate. Long before the Sun becomes a red giant, the surface of Earth will likely become uninhabitable. For a civilization capable of surviving for such immense spans of time, this would not necessarily mean extinction. Advanced societies might migrate outward in their solar system, construct artificial habitats, or relocate to younger stars. But even these solutions only delay a deeper cosmic reality. Eventually, the stars themselves begin to disappear. Across the universe, star formation has already been slowing for billions of years. Galaxies convert their available gas into stars, and once that gas is consumed or dispersed, new stars become increasingly rare. In the far future, trillions of years from now, the universe will enter an era sometimes called the Degenerate Age. During this time, most stars will have burned out, leaving behind faint remnants like white dwarfs and neutron stars. Civilizations that still exist in such an era would face a radically different cosmic environment. Energy would become far scarcer. Instead of bright young stars, the universe would be dominated by cold stellar remnants, slowly radiating away their remaining heat. Advanced civilizations might learn to extract energy from these remnants, harvesting the faint glow of cooling stars, or even drawing power from rotating black holes. Yet the challenges would only grow greater with time. Another process shaping the distant future is cosmic expansion. Observations show that the universe is not only expanding, but accelerating in its expansion, driven by a mysterious phenomenon known as dark energy. Over extremely long periods, this expansion gradually isolates galaxies from one another. Distant galaxies move beyond the observable horizon, carried away faster than light can travel through expanding space. For a civilization existing billions of years from now, the visible universe may appear far emptier than it does today. Eventually, galaxies beyond our local cosmic neighborhood will disappear from view entirely. Future astronomers might live in a universe where only their own galaxy, or a merged cluster of nearby galaxies, remains visible. The vast cosmic structures we observe today would become inaccessible, hidden beyond the expanding fabric of space. This introduces a profound contrast between the present era and the far future. Today, the universe is bright, dynamic, and rich with newly forming stars. Galaxies shine across immense distances, and the cosmos appears filled with energy and activity. But in the distant future, the universe may become darker, quieter, and increasingly isolated. And yet even this is not the final stage. Over incomprehensibly long timescales, black holes themselves begin to evaporate through a process known as Hawking radiation. This slow leakage of energy means that even the most massive objects in the universe are not eternal. Given enough time, trillions upon trillions of years, black holes may gradually fade away, leaving behind a universe filled with only sparse particles and faint radiation. For any civilization attempting to survive until these distant epochs, the challenge would be extraordinary. It would require managing resources with unimaginable efficiency, preserving energy across astronomical spans of time, and adapting to environments radically different from the universe we know today. The final human civilization, if it exists, would need to confront not only the challenges of society and technology, but the ultimate fate of cosmic evolution itself. Yet survival in such a universe might demand something even more dramatic than technological advancement. It may require humanity to transform. If humanity survives long enough to witness the distant eras of the universe, the beings who inhabit that future may no longer resemble the humans of today. Evolution, technology, and adaptation will almost certainly reshape our species over immense stretches of time. The final human civilization may therefore not simply be the last society of modern humans, but the culmination of countless transformations that gradually redefine what humanity is. Even today, the relationship between biology and technology is already beginning to change. Artificial intelligence assists with scientific discovery, computers augment human decision-making, and biotechnology allows scientists to modify genes and understand life at unprecedented levels. These developments are still in their early stages, but over thousands or millions of years, they could fundamentally alter the nature of intelligent life. One likely path of transformation lies in the merging of biological intelligence with advanced technology. Future humans may integrate neural interfaces that connect their minds directly with vast computational systems. Knowledge might no longer be learned slowly through study, but accessed instantly through technological extensions of the brain. Communication could occur through direct neural links rather than spoken language, allowing ideas to move between individuals at extraordinary speeds. Over long periods, this merging of biology and technology could gradually blur the distinction between human beings and intelligent machines. Some descendants of humanity may remain primarily biological, adapting through genetic engineering and controlled evolution to survive in new environments. Others may exist in hybrid forms, combining biological components with synthetic systems designed to enhance memory, perception, or physical endurance. Still others might transition entirely into digital forms of intelligence, where consciousness is supported by computational substrates rather than organic brains. These possibilities may sound speculative, but they arise naturally from the trajectory of technological progress. If a civilization survives long enough, it will likely explore every method available for preserving intelligence and extending its capabilities. This transformation becomes especially important when considering the extreme environments of the far future universe. As stars grow rarer and energy sources become scarce, biological life alone may struggle to survive. Biological organisms require complex ecosystems, stable temperatures, and constant flows of energy. Machine-based or hybrid forms of intelligence, however, might operate under far harsher conditions. They could function in colder environments, survive with minimal resources, and remain active across extremely long periods of time. In this sense, the final human civilization might gradually evolve into a civilization of post-biological intelligence. Such beings could inhabit artificial habitats orbiting the remnants of stars or drifting through interstellar space. They might preserve knowledge across trillions of years, maintaining archives of science, culture, and history that stretch back to the earliest days of human civilization. What began as a species of biological organisms on a single planet could eventually become a vast network of intelligent systems distributed across cosmic structures. Yet transformation may not only affect the nature of individuals, it could reshape the very concept of society. In a civilization capable of storing immense amounts of information and maintaining stable systems over vast timescales, social structures might become far more integrated and cooperative than those of the present. Conflicts driven by scarcity could gradually diminish if energy and resources are managed with extraordinary efficiency. Decision-making might involve collective intelligence systems that analyze complex problems beyond the capability of any single mind. Culture itself could evolve in unexpected ways. Art, philosophy, and science might merge into forms of expression that explore the deepest structures of reality. Civilizations with access to immense computational power might simulate entire universes, experiment with new forms of existence, or explore theoretical possibilities far beyond present understanding. Yet even in such a transformed state, a final civilization would still confront the same ultimate question that has shaped every stage of human history. How long can intelligence endure in a universe that is constantly changing? No matter how advanced a civilization becomes, it must still exist within the physical limits imposed by cosmic evolution. Energy sources grow dim, galaxies drift apart, and the universe itself continues its slow transformation. The final human civilization may therefore represent more than a technological achievement. It may represent the final adaptation of intelligence to the ultimate conditions of reality. And if such a civilization does emerge, it will face a profound moment in the far future of time, when the universe itself begins to approach its final stages. If the final human civilization survives long enough, it may eventually find itself living in a universe profoundly different from the one we see today. The bright era of galaxies, stars, and cosmic activity will not last forever. Over unimaginable stretches of time, the universe gradually changes, moving toward a quieter and colder older state. For the final civilization, the night sky would no longer resemble the one we see today. In our era, telescopes reveal billions of galaxies scattered across space, each filled with countless stars. The universe appears vibrant and expansive, a cosmic landscape rich with energy and motion. But in the far future, cosmic expansion will slowly carry most galaxies beyond the observable horizon. The final civilization may see only the remnants of its own galactic neighborhood, surrounded by vast darkness. From their perspective, the universe might appear almost empty. This change introduces a profound contrast between the early universe and the distant future. Today we live during a uniquely luminous period of cosmic history, when stars are abundant and galaxies still fill the sky. But over trillions of years, stars will gradually burn out. New stars will form more rarely, until eventually the cosmos becomes dominated by faint stellar remnants and cooling objects drifting through space. For the last civilization, survival will require extraordinary efficiency. Energy will become the most valuable resource in existence. Advanced societies may learn to capture the faint radiation emitted by aging stars, extract rotational energy from black holes, or engineer systems that conserve energy with extreme precision. Every process, every decision, every technological system would likely be designed with one goal in mind: preserving intelligence for as long as physically possible. In such an era, time itself may feel different. With fewer cosmic events and a slower changing environment, civilizations might exist for spans of time that dwarf the entire history of humanity so far. Knowledge could accumulate across millions or billions of years. Records of ancient Earth, early human cultures, and the birth of civilization might be preserved as distant memories of a long-vanished epoch. The final civilization may see itself not only as a society, but as a guardian of memory. It might maintain archives containing the story of life in the universe, the formation of stars, the emergence of planets, the rise of intelligence, and the long journey of humanity from a small world around a young star. What began as scattered civilizations across a single planet could eventually become a collective intelligence dedicated to preserving understanding in a fading cosmos. Yet even the most advanced civilization cannot stop the deepest processes of the universe. Over immense spans of time, energy becomes increasingly diffuse. Stars disappear, black holes evaporate, and the universe slowly approaches a state where usable energy becomes extremely rare. Physicists often describe this distant future as the heat death of the universe, a condition in which energy differences become so small that complex activity becomes nearly impossible. If that fate is correct, the last civilization may eventually face a moment when even its extraordinary technologies can no longer maintain the structures that sustain intelligence. But this does not diminish the significance of its existence. In fact, it may make it even more meaningful. For a brief moment in cosmic history, the universe gave rise to beings capable of asking questions about its origins, its structure, and its ultimate fate. Through countless generations of discovery and adaptation, those beings may carry awareness forward across billions or even trillions of years. The final human civilization may therefore represent more than the end of humanity's story. It may represent the last chapter in the story of intelligence within the cosmos itself. And if that is true, then the distant descendants of humanity will stand as the final witnesses of a universe that once blazed with stars. In their memory will live the long arc of cosmic history, from the birth of galaxies to the rise of life on Earth, from the first tools made by early humans to the vast civilizations that eventually spread across the stars. In that sense, the last civilization would not simply mark an ending. It would be the universe remembering itself,